neutralization. Okay, the first method is Hazeltine neutralization. In Hazeltine neutralization, as you can see the diagram, I'm going to have the conventional Y parameter circuit only. You see these four components will come by default. At the output side, you have capacitance, inductance, and then load resistor. And from here, I'm going to connect the feedback component Cn. Cn is going to be my neutralization capacitance or the feedback capacitance. So this method of Hazeltine neutralization is very, very popular. Okay, it is going to be very, very popular, and it is also having a very good capacity to cancel out your oscillations. So this is the neutralization technique which is employed in RF amplifiers. So whenever you go for high frequency, there the stability of circuits becomes a question mark. So in those cases, I'm going to use this Hazeltine neutralization method to ensure the stability of RF amplifiers. RF means radio frequency, okay, more than 1 megahertz. So the concept is that one what they do. This is the conceptual diagram of using a Y parameter. Now in the circuit we'll see how it is practically implemented. So I'm going to give input and I'm using a transformer to isolate my input and the amplifier. Okay, so by using transformer, the input will be separately available. The amplifier will be separately available. There is no connection between them. So it is just like when you're using a transformer, the input and the amplifier are only coupled inductively and they are not directly connected. And R1, R2 is biasing resistors. And this is your common emitter amplifier. You have REC, bypass capacitor, and emitter resistance. And you see, we have seen the hybrid pi model of a transistor where at high frequencies this capacitance CBC will become dominant. CBC is between base and collector. So this capacitance is going to act like a feedback component. It is going to generate positive feedback. For cancelling out the feedback generated by this capacitance CBC, I am connecting a neutralizing capacitor Cn in the opposite side between base and the output. And I am see one end of Cn is connected to base, another end of Cn is connected to the center trap transformer. For center trap transformer means you see CBC connected between base and upper portion of center trap transformer. So if this polarity is going to be plus, this will be minus. So when this capacitance is going to add a positive feedback of plus 5 volt, the Cn will add a positive negative feedback of minus 5 volt, and at base both are getting added and it will get cancelled. So the logic is you have to completely cancel out the feedback generated by this capacitance CPC. So I connect the one more capacitance Cn called as neutralizing capacitance at the same base junction, but the other end is connected to the other side of the transformer. If you don't do the center tapping, then both the voltages will not be opposite and it is going to be same and the purpose is not going to be achieved. So only center tap transformers will have change in polarity on the top. Same winding, the upper portion will have one polarity, lower portion will have one polarity. That's why I'm using center tap transformer, and across the output of the secondary, I'm going to take the output